Thank you, and welcome to this year's Developer Tools session. My name is Chris Hagedorn. I am a senior software engineer here at Roku, and today I will be covering three main topics: Roku Resource Monitor, the Roku Debug Protocol, and something new with Perfetto. Before we get into all of that, here is the QR code for the Q&A. I will pause here for a moment and give you a chance to snap it. And I will also put this slide back up at the end of my talk. All right, let's dig in. First up is Roku Resource Monitor. For those of you who may not be familiar with this tool, Roku Resource Monitor, or RRM as we sometimes call it, is our visualization tool for tracking system and channel resources on a Roku device. And so some examples of the types of data you can get out of RRM are the amount of system and graphics memory that a running channel is using, the amount of CPU it's using, the number and duration of the rendezvous that it's generating. And that's important because, as I'm sure many of you know, minimizing the number and the duration of the rendezvous in a channel is one of the most effective ways for improving performance. You can also see information about registry usage. You can see all of the signal beacons that a channel is firing. And you can get data about the number of bright script objects and scene graph nodes that a channel is creating, as well as information about the memory that they're using. And even more, right? These are the highlights, but there's plenty of other data you can get out of Roku Resource Monitor. So what's new in Resource Monitor in the last year since the last Dev Summit? The latest and greatest version of the tool is 4.2. It requires Roku OS 14.5. And in the last year, we have made a number of performance and stability improvements, and we've also added some pretty cool new features. Starting off with an improved panel configuration UI. So those of you who have used the tool know that managing all of the different panels that are visible in the tool can be a little cumbersome. So every single panel has two different controls, one for enabling and disabling it, and then another for collapsing and expanding it. And even when a panel is collapsed, its title bar is still there, taking up space in the main UI. So this year we have completely reworked panel configuration, and we think we've solved a lot of those problems. And I will show you this in a little more detail in a little bit. Something else we've improved this year is scroll bar behavior. So in the past, if you were trying to scroll through a very large data set, a very long session, there were times when scrolling could get kind of jittery and jumpy, and it might scroll to somewhere you didn't think you were telling it to go. And also there were times when if you were trying to scroll multiple different panels together, they could get out of sync. So this year, we've made some changes to improve that, and scrolling behavior should be much more smooth in the latest version. This year, we've also improved the accuracy of registry limits in the tool. So in the registry usage panel, there is an indicator of the maximum amount of registry space your channel is allowed to use. In the past, that number was hard-coded, and that was correct for a very long time, but nowadays that's not always correct because different channels can have different limits based on all kinds of different factors. And so now we are getting that number from the device itself. It's no longer hard-coded, and so that upper limit on registry usage will be more accurate in the latest version of the tool. We've added memory usage data to the scene graph node and bright script object panels. So these are panels that existed before. In the past, they would tell you the number of scene graph nodes or the number of bright script objects your channel was creating, but that was it. And now this year, we've added the ability to also see how much memory those objects are using. And I'll also show you that in a little more detail later on. We added thread filtering to those same two panels. So scene graph nodes, bright script objects, you can now, in both of those panels, filter by thread. So if there's a specific thread in your channel that you want to see data about, you can now do that easily. We added support for very large session files. So in the past, if you recorded a very, very long test session, the tool would happily let you download a data file that was bigger than 500 megabytes. But if you then went back and tried to reopen that data file, you would get an error and it wouldn't let you open the file. So we fixed that. You can now open very large data files, which, in addition to solving that existing problem, also went a long way to enabling what we call data collection mode. This is a new way of using Roku Resource Monitor. It's a command line interface, no heavy UI like we've always had in the past. And we think it's going to be very useful for automated testing, CI pipelines, things like that. You can even use it in a Docker image. All right, let's take a look at some of these features in a little more detail. So this first screenshot of it is of that new panel config UI I talked about. No longer are there the two different controls on every single panel. No longer do you have to deal with the title bar still being there even when you've disabled and collapsed a given panel. Now it's all done through this new panel config UI, and it's very simple and clean. You have a list here of all the different panels that are available in the tool, and you can turn them on and off at will. And if you turn one off, it will be completely removed from the main UI. You won't even see its title bar. The other thing that's nice about this is that when you turn a panel off through this config, the tool will no longer pull the device to get the data for that panel. That's helpful because if you've used the tool in the past, you know that if you have a bunch of different panels going all at once, or if you have a very frequent polling interval set, the impact the tool has on the running channel on the device can be significant, right? The act of gathering the data can slow the channel down quite a bit. And so this allows you a way to, if you're only interested in a very small subset of this data, to only turn on the ones you want, then the tool will only pull the device for those specific things, and the impact on the running channel will be significantly less. This next screenshot shows the new memory usage view in the scene graph node panel. So the scene graph node panel and the bright script object panel both now do this. You can see at the top we have tabs. The old count tab is still there, so you can still see what you could always see, the number of nodes being created. But now we have this new tab labeled memory, and when you navigate over to that tab, you get this view, which shows you the amount of memory that those nodes are using. And so in this example, we can see that the labels that this channel has created are using 0.15 megabytes of memory, right? And this was a simple test channel. So these numbers not reflective of a real world channel, but they give you an idea of how this works. Okay, this next screenshot shows the filtering, the thread filtering on those panels. So again, the bright script object panel and the scene graph node panel both now have this thread filtering. So when you're in those panels, you can come into this dialog. It'll give you a list of all the threads that have existed during the channel session that's currently active. And you can select exactly which threads you're interested in. And then when you go back to the panel, it will only show you data for those threads. And lastly, this is the command line help for data collection mode. This is the headless command line interface that I talked about. So you can give it some basic information about the device that you want to test and the channel you want to test. You can give it the IP address and the channel ID. And in addition to that, you can give it a few other parameters to configure how it's working. You can tell it where you want it to spit the output file when it's done. You can tell it exactly which panels to enable. And again, just like the new panel config, this gives you a way to control which panels it's actually going out and fetching data for. So if you're only interested in a small set of data, You can tell it exactly which panels you want, and then it will only collect data for those panels, minimizing the performance impact on the channel running on the device. You can also set the polling interval, similar idea. The longer your polling interval, the smaller the impact on the channel running on the device will be. And if you're interested in seeing some of these features in even more detail, we did a full webinar earlier this year all about Roku Resource Monitor, and I would encourage you to check that out. Okay, let's talk about debug protocol. Again, for those of you who aren't familiar, the debug protocol is our socket-based binary protocol primarily used for enabling IDE integration. So what does that mean? If you're using VS Code to do your Roku channel development and you're using the community Bright script extension for VS Code, that extension is in turn using this debug protocol to do all the things it does. Right. And so just to give you an example of some of the things that it's capable of, you can use it to start and stop execution of a channel on a device. You can use it to manage the breakpoints in the channel you're developing. You can use it to inspect all the variables that that channel is creating. And you can also use it to get stack traces about the channel running on a device and more, right? These are the highlights. There's lots of other stuff debug protocol can do. So what's new in debug protocol in the last year? The big one, for me at least, is improved stepping speed. I think it's fair to say that the biggest piece of feedback we've been getting about debug protocol in the last year is that in certain situations, stepping can be very, very slow, on the order of multiple seconds to complete a single step. And we understand that can be frustrating. And we have made some changes this year that dramatically improve that situation. So you should see a noticeable improvement in stepping speed in the latest version. The other new big feature this year with debug protocol is support for virtual variables. So what this is a way for you to access metadata about a variable in a running channel that normally you would have to call a function to get without actually having to call that function, right? Basically, we're doing it for you at the system level, which is much faster than you calling that function manually through the debug protocol. And so just as an example, there will now be, if you have a variable of type node in your channel, there will now be a property on it called parent. And the value of that property will be the result of a call to get parent, but you don't have to call get parent to get that data. It'll just be there for you. And so similarly, there's a property called children now that maps to get children, or count, or the scene, or thread info, and many more. Again, these are just a few highlights. There are several others that we support now. And there's more coming. This is something that we see as a starting point. We want to add more over time. And we're looking to your feedback to help us with that. So once you get access to this feature and start using it, we're eager to hear what other virtual variables you would like to see support for. And that's debug protocol. So last but not least, I want to talk a little bit about something new we've been working on with Perfetto. Now, before I get into this in any detail, I need to say that this is a preview of an unreleased tool. So the things that I'm about to show you may not exactly match what ends up being released, but it should give you a good high-level idea of the direction that we're trying to go with this. So first off, what is Perfetto? According to their website, Perfetto is an open source system profiling, app tracing, and trace analysis tool. This is a tool that started in the Android development world, and we are making an attempt to adapt it for Roku development. Our plan is to make this available to you in Roku OS 15.1. And the way we're going to do that is through a couple of new ECP commands. So there will be an ECP command that you can call to turn on tracing for a given channel. And you'll be able to do this with a sideloaded channel or with a published channel that you have the signing key for. And then once you've enabled it, you run your use case like you always would, go through whatever scenarios you need to. And then at the end, when you're ready to get the data, there will be a second ECP call that you can make to extract that trace data from the device and download it to your local machine. Now, this is not a real-time tool, so Roku Resource Monitor is a real-time tool. You can actually have it running while you're using a channel. You can see data populating the charts in real time as you're doing things. This is not that, at least not yet. For the time being, you have to enable it, run your use case, then download it, then open the data in a viewer and analyze it that way. And I'll show you some screenshots in a minute using the official viewer. The other really cool thing about this tool is that it supports SQL-based queries. So once you have that trace file downloaded to your local machine and you open it in the viewer, you can query it using a SQL type language to explore it however you want, right? It will show you pretty graphs by default, just like Roku Resource Monitor does. But if you need to go deeper or you just want to explore the data in a different way, you can do that by building these SQL queries to dig into the data however you need to for your purposes. So what are some of the types of data that you can expect to see in these trace files? Now, this is a place where this list is not final. This list is not exhaustive. This list may change between now and when the tool gets released. But as I'm recording this, these are some of the types of data that we're thinking about putting in these trace files. So field accesses on nodes. These are things like calls to get field and set field. Rendezvous, again, just like we talked about with Resource Monitor, understanding where rendezvous are happening and how long they're taking is a very powerful tool for improving performance of a channel, right? Understanding how often rendezvous are happening and how long they're taking is one of the most effective things you can improve to make the performance of your channel better. Observer functions, similar, right? Observer functions in general run on the render thread, which means they block rendering. So if you're trying to render a channel at 60 frames a second, which should always be the ultimate goal, that means you have just over 16 seconds between each render to do whatever you need to do on the render thread. And so an observer function that runs longer than that will almost certainly start to drop frames. So knowing when your observer functions are running, how long they're taking is very powerful information for understanding where you could be making optimizations to your channel to improve frame rate. Swap buffers, this lets you see exactly when the system is actually updating what's on the screen and visible to the user. Channel compilation, this is another one that I think is pretty interesting. So as you probably know, published channels are compiled in the cloud and the bytecode is delivered to the device. But the XML files in your channel, that's not true of them. The XML files are always parsed and compiled on the device. And so this channel compilation data lets you see exactly how long it takes to compile each individual XML file in your channel. And I think that's very powerful. And URL transfer activity. This is another thing where almost every time we look at a channel trying to figure out how it could be made better, one of the things we always end up finding is URL transfer stuff, API calls. And if an API call is taking too long, it's going to impact user experience. And so again, being able to see exactly when these are happening, how long they're taking, can be very useful information for knowing where you can make the biggest impact with optimizing your channel. And again, like with Debug Protocol, there's more to come. We see this as a starting point. We want to build on this over time and add even more data to it. And we are anxious to hear what you think about that. Once you have this and start playing with it, we want to hear what other data would you like to see? What's not here that would be useful to you? Okay, let's look at some screenshots. So this first one is the sort of overview of a trace file. So this is a very simple test channel I built. It is setting up a grid and then populating it with some boilerplate data. Things to note on here, this is completely zoomed out, so you're seeing the entire timeline of the launch of that test channel. So I basically just launched it, let it populate the grid, and then stopped the session. On the left-hand side, you can see that it's telling me where the data file was loaded from. So when you extract the data file from a device, you'll save it locally, and then you open it in this tool. I should also say that this tool, the viewer, is not developed by Roku. This is the official Perfetto viewer tool. And again, because it's open source, there are other tools that support the format as well. But all these screenshots are from the official tool. The rows. So if you look kind of vertically down the screen, you see that there are a bunch of different rows with data in them. And the top one says render thread main. That's the main render thread. And then all the other ones below it are prefixed with TN. TN stands for task node. So each of those rows represents a thread in my channel that was spawned by a task node, right? So the names of them, if you look at the names of the individual rows, you'll see that several of them are the same, like TN task progress is there multiple times. That's because I called multiple, I called the same task node multiple times with the same task function, each time getting the data for a single row of my grid. And so in the viewer here, the rows are named based on the task function, not necessarily the task node. So the titles here that you see are the name of the function that I called, not of the task node itself. So if you have a single task node that contains multiple task functions, you can differentiate them that way. Next up, so XML parsing. I talked about this a little bit earlier. So I've zoomed way in on that same trace. This is the same data. I've just zoomed way in on the very left-hand side of the graph. And I've selected one of the slices. And so you can see on the top half of the screen, it's sort of outlined in black. That's the selected slice. And when I select a slice, I can now get this detail panel on the bottom half of the screen that tells me all kinds of more information about that particular slice. So the name is parse component XML. So that's telling me that this slice represents the parsing of an XML file in my channel. And if we look over on the right-hand side of that detail panel, it tells me exactly which file it was. In this case, it was content task.xml. And it'll also tell me the duration of the slice. So back on the left side, we can see that parsing that XML file took a little bit over a millisecond. And then there will be additional slices. You can see to the right of the selected slice, there are more slices that are that same color, that sort of brownish color. Those are all the same type of slice. So each of those will be the parsing of a different XML file in my little test channel, right? And so you can imagine, this is a small test channel with like 5 XML files in it. So you can imagine what this might look like for a huge real-world channel with hundreds or even thousands of XML files in it. And it really goes a long way to helping you understand, where the system is spending time in your channel. Next screenshot shows an observer. So similar type of view. I'm very zoomed in, but I'm farther forward in time. I'm now at the point where the grid is on screen and populated and the user is moving around it. And I'm starting to see observers fire. So again, at the top, you can see one of the slices outlined in black. That's the selected slice. It's labeled observer callback. And when I select it, I get this detail panel, and it can tell me all kinds of stuff about that particular observer. On the right, we can see the name of the function, right? On row focus percent. So this is an observer that's responding to a change in the row focus percent field of my grid, right? And then back on the left-hand side, we can see that particular observer took 523 microseconds to run. Right. And again, similar to rendezvous, like observers, you can see this is running on the main thread. Observers run on the main thread. Anytime you start to see observers taking multiple milliseconds, that's a potential problem because, again, you only have about 16 seconds between each render if you want to maintain that target of 60 frames a second. All right, rendezvous, same idea. I've scrolled over to a rendezvous, zoomed in on it, selected it, and I have details about it, and I can see what thread it happened on. This happened in my task node, my get content task node. We can see that this rendezvous took 11 milliseconds, and you can also see some other stuff around this. So you can kind of see the call stack happening. You can see that in that task thread there was a bright script execution, and then there was a set field on a node, and that set field is what triggered that rendezvous. All right, lastly, I talked a little bit about the SQL query support that's built into Perfetto. So here it is in action. So what I've done here is I've constructed a query to find all the rendezvous in my trace file and to sort them by duration. So, I can do like I did on the previous slide and navigate around visually and click on individual rendezvous and get details about them. But this is a much more powerful way to find things like, say, the longest rendezvous in my channel. So if all I want to know is where's the longest rendezvous in my channel, that can be difficult, scrolling around a graph, trying to look at it visually. And so a much easier way to do it is this. All I have to do is build this SQL query. You can see it at the top where I'm selecting all the slices whose name is RVZ, which means rendezvous, and then I order it by the duration, and I immediately get a list of all the rendezvous in the channel ordered by their duration. And so I can just look at the top of this list and say, okay, this tells me that the longest rendezvous in this trace file was right here, and it is about 41 milliseconds, right? And you can click on it on the left, you see it has an ID number, and that ID number is kind of underlined. That's a hyperlink. So if you click on that, it will take you back to the timeline with that slice highlighted, and you can get that detail view again and see all the other information about that slice. All right, so that's Perfetto in a nutshell. We're excited about it. We can't wait for you guys to get your hands on it, and we're excited to hear what you have to think. Here is the QR code again for the Q&A. I'll leave it here for a second, and then I will throw things back to the Q&A session.
Hello. Welcome to the Developer Tools Q&A session. So just a general disclaimer for all our panels, we're just going to do this once. I won't do this every time. You guys are all wily veterans of this proceeding. So as you guys ask a question on Slido, the fellow attendees will get to upvote or downvote, and that will determine which questions get read on air. You can also, it's possible that if we want to elaborate on a question, we can use the Zoom's raise hand feature if we need to. And then be mindful also when we use that raise hand feature that all the attendees can hear your question. Also, please be aware that we'll not comment on a roadmap or make other forward-facing commitments. We do welcome feature requests and any other suggestions that'll help make our platform better. And as also a reminder, if you need to leave, you want to share this later, we will have the keynote and all the panels on our usual channels. That includes our YouTube channel, the developer portal, and the on-device channel. Okay, so without further ado, let's get started with the Q&A. Our team is here, ready to go, and the exciting part is we do have a lot of great emulator questions. We're going to start with something very basic. Marcelo asks, can we have dark mode on all the developer tools?
We will certainly take that back and take it under consideration.
All right. Next question. Currently, it is really hard to identify the root cause of timeout crashes on the apps. Most times are not reproducible by the team, but in live, we have several timeout crashes and crash reports. Will the Perfetto integration allow us to better identify the root cause of timeouts?
I think potentially, yes. That's certainly, we are aware that that is one of the things that's most difficult to identify. So yeah, that's on our radar.
Next question. On the cloud emulator, is the plan to have a desktop or web-based application to visualize the device? I assume video playback will be blacked out just like screenshots today.
You'll actually have video playback depending on your DRM license. So if you have DRM level 1, which requires hardware, we won't be able to play that back and it'll be black. But if you have DRM level 3, then we can because it's software decode.
Okay, awesome. Yeah. For the emulator, will we be able to sign a package?
Yeah, you'll be able to sign packages. So the emulator is going to behave just like a device will. So you'll link it like a normal device. You'll go through all the normal processes for setting it into developer mode and sideloading apps and signing packages that will all work on the emulator.
Excellent. For the next emulator question, will there be an authentication process to gain access to a device?
That's really yet to be defined on how we get access to the cloud emulator, and we're still working on that release process.
Cool. The next emulator question: are there plans to support picking the model of device being emulated?
Yeah, so currently we support like TVs, so device profiles, TVs, players, and stream bars. We're not yet sure about to what extent we can realistically emulate different performance levels. That's of various platforms. That's a fairly complicated equation, but under discussion also internally to what extent that's possible.
Okay, excellent. Thank you. On application rollouts, it was mentioned that you could pause and cancel the rollout. Could you only pause without canceling and restart the rollout at a later time, or is the pause and cancel always a mutual action? And I think actually this one, this may be more of a developer portal question that we could direct to Tom or not.
I think so.
Yeah, that's right.
So we're just getting it. Yeah, you can pause. I'm sorry. Sorry, I misheard. You cannot. You can only cancel. Chris, if you want to actually further elaborate on your question, just put that in the developer Slack and we'll have Tom go communicate with you. All right, next question. Why has the automated channel testing repo been abandoned for over 3 years? There are some legitimate community issues and pull requests and zero movement.
I think maybe about the BrightScript automation framework.
Yeah.
Yeah, I don't know, Ron, do you know if there's been anything new on that?
We can collect the requests and look at them and see what we can do with them.
So Charles, go ahead and just put your question in the developer Slack and we'll have the DevTools team take a look and comment further on that. Brian asks, how is the performance of Perfetto in comparison to BS Prof? It can be pretty heavy on device performance. At the profile, it can be heavy.
Yeah, Perfetto definitely has less impact on the running channel. This initial release of Perfetto will be an all or none. You'll get all the data we support, and there's no way to sort of filter out just individual bits like you can, like with Resource Monitor, for example. But we do have some ideas about how to fix that in the future and make it so that even with Perfetto, you could say, I only want to collect these certain pieces of data, and that would reduce it even further. So yeah, I think in all cases, I think Perfetto has less impact on the device than BSProv does.
Okay. Okay, Bronley. Would love the ability to fire custom profiling beacons to help track our own custom performance scenarios. How heavy of a lift would it be to add something like this to the new Perfetto implementation?
That is on our radar. I think it would be very useful. We're still talking about how exactly we would do it.
Okay. Okay. Is the cloud emulator a free service or paid? How will that work?
Yeah, I'd say it's yet to be defined at this point.
Okay. The next emulator question is will it be able to run NDK apps?
It runs the whole of Roku OS, so yes, but that's not the focus. NDK apps, RSG apps are the focus.
Are there any improvements planned for the profiler, or is that becoming obsolete with Perfetto coming out?
Definitely not becoming obsolete anytime soon. I'll let Ron talk to planned improvements.
Yeah, we will continue to put in any performance issue fixes that you see. Over time, we do see that you'll get more data out of out of Perfetto, but Profiler is not going obsolete anytime soon.
Okay. So Matt asked, and I think we already kind of answered the first half of this question, will the cloud emulator be able to be provisioned to create packages, which I think we said yes, or run automated tools for things like nightly builds and so on?
Yeah, the answer to that is yes. There will be a command line interface as well that you could integrate in CI pipelines.
All right. With Perfetto, is it possible to gather performance data across multiple devices simultaneously, similar to how New Relic aggregates information?
Not in all-in-one trace file, but you could
Well,
certainly.
Perfetto is intended to analyze a particular performance problem on a device under test. So it's not like a metric collection system. You just run a session to analyze a particular problem. So it's not the same as New Relic.
But if you were interested in, say, collecting this data about the same test use case across multiple devices, you could certainly build a script that ran that use case on multiple devices and extract trace
Yeah,
for each one and then compare them. So
yeah, you could do that, but it's not like a large data platform
correct.
type thing, right?
Okay. How fully will the device emulator represent the real device? Do you anticipate this being accurate enough for developers to get rid of older devices such as Littlefield?
Functionally, yes. In terms of performance, no. And there's some unique problems to that, right? The performance characteristics. And we don't currently know how to really accurately emulate the performance, right? This is a function of like GPU or the lack thereof, CPU performance, caches, DRAM throughput on the bus. So it's quite a complicated thing to simulate properly. So you'll always still need devices.
Okay. All right. Would it be possible to integrate the cloud emulator with continuous integration as test devices?
Yes.
This question, I have to assume this is in relation to the emulator. But do you have any plans to support HLS interstitials or multi-view?
I don't think there's anyone on the call here that can talk to the media and multi-view questions here.
We have a full export of all the Slido questions. That's something we can forward later on to those teams. All right, so next question. Has Roku tested the cloud emulator with the VS Code extension debugging features, either the debug protocol or Telnet? Does it work out of the box?
Yes.
Will we get to pick the OS version in the cloud emulator, and how far back will it go?
Yes.
And do we know how far back?
Don't know how far back, but
Fair enough.
in principle, you can put any build on it and select any build.
Okay. When can we expect the aforementioned new APIs for crash reports? That's good. I think that's a question for Tom.
Yes,
Okay.
I think that's a dev portal question of Tom.
Yeah, so I think that's coming soon sometime in 2026. Yeah. Guys, please keep asking questions. This is your opportunity. And have, whatever, all your tool related questions, please fire them away. We were, all right, Kevin. So we were talking about this already internally ourselves. Will we ever get in-person summits again? That all depends on there's a lot of macro factors involved in that. And so our goal is always to do these in person, but there are things like, the economy itself is a big factor. And whether we feel that we're going to get the commitments to have a full house at our event center. I mean, we're cognizant that we have a beautiful, beautiful event center that can hold hundreds of people, and we would love nothing more to have everyone here in person. And I hope we get there. I do. But we'll see as we start doing the planning for the 2026 Dev Summit. That is usually when we talk about how we prioritize the big questions as far as the look, the feel, but the number one thing we ask about, like that dictates everything, is, are we doing this in person or are we doing this remotely? And our goal is always, and we're always striving as a team to get this in person. So at least you know that we're working and our goal is to get this in person for sure. I think that's a long way of saying I'm not sure. Straightforward analytical answer, I don't know. But that's our goal. All right, next question. Are there any HDCP considerations with the cloud emulator?
I think I covered this in the first cloud emulator question, but basically it depends on the DRM level that you're using. And the cloud emulator will only work with DRM level 3. So any hardware DRM is not supported, and we won't be able to play back those streams.
Okay. We have another crash reports question. What will the format for the API for crash reports be? Will it be more like JSON, like we used to have access to? We're still, as it's going to be released in 2026, we're still finalizing formats and things like that. So as the release gets closer, we'll have more details. So next question, the packages signed by emulators will be publishable? In summary, can we integrate the emulator as part of a Jenkins CI CD to publish the apps using the new publish API?
Yes. So we'll sign packages just like a normal box would.
Okay. Next question. Any updates on other tools, Roku Remote?
No updates for this year for this.
And then I'll take the emulator is planned for 2026, correct? Any idea in the quarter? It's going to be sometime in 2026. I don't think we can commit to a specific quarter. Any cool things you are all doing with GitHub Actions and the CLI tools? Maybe not. Maybe we move on to the, we're going to move on to the next question. When we'll be able to load older Roku OSs to physical devices?
I don't think there's a plan for that.
All right, next question. Will we be able to turn on Perfetto logs mid-session and turn them off as well through ECP commands? This would allow us to focus on a particular part of a journey.
Yes.
Yes.
So, at the moment, and this will probably change, but at the moment, there's a buffer limit of, I think, 8 megabytes, and that's as big as a trace file can get. And so at the moment, you kind of have to do it this way, and do, if you have a longer session, do it as multiple trace files. So yes, there will be an ECP command to basically reset the session.
Okay, next question. And it took 50 minutes into the Dev Summit to get our first AI-related question. Have you reached out to OpenAI or Amazon to discuss teaching an AI copilot or teaching a LLM to develop BrightScript?
Not that I know of. I mean, I know that there are LLMs that can do BrightScript, and we are looking at them, but I don't think we've specifically talked to, or that I can't talk about whether we've talked to other companies about it.
All right. Matt asks, will Perfetto logs be able to be generated by the emulator?
Yes.
Yes.
And then for any news regarding API for automatic publishing, we will go ahead and put those in the developer Slack. So. Any plans to have server-to-server APIs for continue watching integration? That question, actually, I will stop right there. Let's ask that tomorrow in our content discovery panel, because that team actually handles the continue watching integration. So let's save that for tomorrow. Come back tomorrow. It's a great session, and so let's do that then. Oscar asks, will the new emulator be able to emulate different Roku device classes, such as live TVs, ultras, and express models?
I think we already addressed this question. So you can't, we do have categories of devices, TVs, players, and stream bars. We don't currently emulate different performance levels.
Okay. Are the Perfetto file formats something that could be streamed in the future?
Yes.
Okay.
We want to overcome this 8 megabyte limit. So.
Can you trigger turning on Perfetto on a production channel?
Yes, if you have the signing key.
All right. A lot of great questions. Guys, feel free to keep firing away. Got a few more minutes before we need to move on to the next panel. But if you have any last minute questions, let's get them on the board. Any questions? Any last minute questions before we move on? So Kevin has a clarifying question. On that last question, I was referring to an actual published channel to help find problems.
If you sign your device, yes, with your sign-in key.
Okay, next question. Any thoughts, updates regarding the ability to share encrypted sideloaded builds so we're not required to share our source code when attempting to debug issues?
Yeah, we consider that a security issue, so we wouldn't allow you to upload signed packages or sideload signed packages.